This is Programming Chapter 4. We're going to look at control statements. We're going to look at the do while, the while, and the for. So, again, executing statements one after another has limited use. And to do more complex programs, we need to be able to loop a certain number of times and stop. If we don't stop, then this is an infinite loop. The operating system is a program that runs from power on to shutdown, and this is an infinite loop that is done on purpose. Beginning programmers might create an infinite loop accidentally, and this is an error. We have seen these statements before without explanation. Here's the syntax for the looping statements, and we're going to start with the do while because we've already used them to run programs until a sentinel is entered. So the do while statement is the same for Java, Objective-C, and C++, as well as other languages. So we have a do, and it does one statement. If you need more than one statement, you can use a block statement. So it does that statement at least once, and then checks the condition. As long as this condition is true, it'll keep looping back. Once this is false, it will fall out and execute the next statement. So the important thing to note is a do while will execute the statement at least once and will continue to do so as long as this condition is true. However, there is a way of stopping this loop, and it's using a break statement, and we've done this in exercise 2.3. The while statement is again the same for all three languages. So we do a while. We check the condition. If the condition is true, we execute the statement, and then it goes back up and checks the condition again. Once it's false, it will drop down to the next statement. So this difference with the while statement is it does not have to execute the statement at least once. So if the condition starts off as false, it will never execute the statement. And we can also break out of a while loop using the break statement. The for loop statement. We can have an initializer, and it's normal to have one. We have a condition, just like the other two. And we also have an increment or decrement operator. And again, all these are optional, but you need a statement. And again, if you need more than one statement, use a block statement. Notice the statement is a clause. We don't use a semicolon here because these two lines form a statement. And again, no semicolon here, and no semicolon here. Now, in theory, we can always use only one looping method. However, by convention, we do choose the proper looping statement. So if you know how many times you're going to loop, then choose the for statement. So if you're going to count from 1 to 10, use a for statement. And other examples, when we're calculating average, a minimum, or maximum from a list of numbers. So if we have a fixed size list, then we use the for statement. If we don't know how many times we want to loop, and we need to decide whether we loop at least one time or not, choose between the do while or the while statement. Examples of this are using the input loop, such as what we've done with the console, but we can also loop over a file or an external device. So, exercise 1, we need to write a program that calculates the first 100 triangular numbers. And the formula for the triangular numbers is just a sum of sequence of natural numbers. So the first one is just 1. The second one is 1 plus 2, that's 3. And then we continue 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, 1 plus all the way up to 5, and so on. And we're going to use exercise 4.1 as a template. And it's always good to do some calculation by hand to get the correct initializer and condition. So here's a sample printout, but let's go to the program. We're going to calculate factorials from 0 to 12. I know that because the initializer is 0, and we stop after it's bigger than 12. We call the factorial function. The factorial function checks to see if the number is less than 1. And because this is a special case, 0 factorial is meant to be 1. And for anything less than 0, we'll just say 1 so that we don't get an error. So the factorial starts off as 1. And we start the loop at 2, because if we have 1 factorial, it's just 1 without any multiplication. If we have 2 factorial, this number will be 2. We start off at 2. Since 2 is less than or equal to 2, it'll execute this one time. So f will get multiplied by 2. Once it's 3, it will exit and just return 2. And if num is 3, it'll just multiply 3 times the previous factorial number, which is 2. And then after it hits 4, it'll return. So let's just run this. And we see that it prints out the factorials. Factorials get large very quickly. That's why I decided to stop at 12. It can handle a slightly larger number if you need to, but not much larger. Okay, so your task is to modify this routine here. Pick your right conditions in order to compute the triangular numbers. So, for any loop, you may or may not have an initializer, and you should have something that changes the condition. So if we look at this one, we're changing I every time we loop. If you don't have something changing, you'll have an infinite loop. And again, we have the increment or decrement. And the condition checks the counter here. So your next program, if you've done exercise 4.1 correctly, it's not going to be hard to complete this program. You're going to calculate the first 100 pyramid numbers. It's simply the sum of the square of the natural numbers. So 1 squared is 1. Then we do 1 squared plus 2 squared, that's 5. 1 squared plus 2 squared plus 3 squared, and so on, all the way up to 100. Now, we're going to do another exercise, and we're going to print the sum of a list of numbers that the user enters. So we have 2 sentinels in this case, one to actually quit, one to calculate. After you calculate, it'll start the input again from fresh, and then you can calculate another sum of numbers. So let's look at exercise 4.3 and see what you need to do to modify this program. So this one will calculate the average of a list of numbers. So it asks the user to enter one number at a time. We initialize the sum to 0 because we don't have any input yet, so it should be 0. The number of integers. We need to count the number of integers entered in order to calculate an average. So we have input like before, except we check for the extra sentinel, C. So both of these will break out of the loop. We have a flag here called continue. I can't actually use continue because it's a reserved word, so it's abbreviated. So it sets it to true at the beginning. So it's going to always want to do this outer loop. And when we enter Q, it sets it to false. So once we enter Q, it'll exit out of this infinite do loop. If we press C, we break out of this input loop. However, because continue is still true, it will calculate the average and go back to the top of the loop to enter another list. Here, we convert this input into an integer like before. However, now we sum. It's a plus equals. So this really means sum equals the old sum plus the input value A. And here, this plus plus just means we're incrementing this variable by 1. So once we break out of this loop to do our calculation, The integer average is simply sum divided by number ints. However, the decimal average is going to be slightly different. So we need to convert it, and this is called casting, to a float. We're changing this integer into a float and then dividing by our number of integers. So let's run this. Okay, I'm going to enter 1, 2, 3, 4, 5, and then I'm going to press C. So the sum of this is 15. There's 5 numbers, so the average is 3. The decimal average is also 3. So I'm going to enter 1, 2, 3, 4, 4. The sum is slightly less than this. You can see that if we do an integer divide, it rounds it down. The decimal value is 2.8. So you always have to be careful if you need to round off to the nearest. You can't just do a divide. And we'll get into this later. Okay, so it shouldn't be a difficult modification to compute the sum. So previously you wrote a program to calculate the min and max of 3 separate variables. Using an array, this should be a lot easier. To compute this, you need to just check each input value as you get it to see if it's a min or a max. I think you'll find this relatively easy, but ask if you need help. This completes part 1 of chapter 4, and watch part 2 after you've done these exercises. And that completes this lesson.